Adelaide Sustainable Building Network acknowledges the Kaurna people of the Adelaide Plains as the traditional custodians of the land we live on, and Tanya, where most of our work is undertaken. We pay our respects to elders past and present of all Aboriginal nations. As professionals in the built environment, I'm hopeful we can use our work practices to look after country in the same way country looks after us. Nina Mani, everyone.
Yeah.
Rightio.
Thank you very much, Christina, and welcome everybody. I have the pleasure today to introduce our speaker for today. So Kim has an extensive background in water and waste treatment, having worked both in sales, marketing, distribution, and general management for water treatment companies, as well as in operations, maintenance, and management of major treatment plants. He's familiar with virtually all treatment technologies, and after managing the fifth largest water filtration plant in the world, Kim lent his hand to developing a strategic business plan for a startup company and stayed on as CEO to grow the company. Clarity Aquatic offers a nature-based water and wastewater treatment solution that uses constructed floating wetlands, or CFWs, to remove nutrients from water bodies using plants. The CFW modules link together using special keys to form stable, robust, UV-stabilised islands containing baskets with plants where the roots grow down into the water bodies, form biofilms, and suck up nutrients. The plants are periodically harvested, sequestering carbon and removing nutrients. So thank you very much, Kim Falster, for coming on today. Very warm welcome, and over to you.
Thank you very much for the introduction. Look, it's really good to be able to talk to you and a group that is involved in SustainabiliTEA, enjoying the tea as well. What I'm going to talk to you today about using constructed floating wetlands as a nature-based water treatment solution. So what I'll look at, the aim is to look at how we can use wetlands to remove nutrients and to clean up water bodies, including dams, ponds, stormwater, effluent ponds. And it is a truly nature-based positive treatment solution. As Sam introduced me, I have worked in just about every form of water and wastewater treatment, and it's refreshing to be able to find something that is truly sustainable and nature-based for cleaning up water. So water is an essential and valuable resource. Water and wastewater treatment normally, invariably uses high capital costs for installation, use a lot of energy, and it's got high operation and maintenance costs. The floating wetlands use plants to clean up the water bodies. The roots grow into the water body, forms a biofilm, and uptakes the nutrients. And nominally, you can remove 50% of phosphorus and nitrogen from the water, and it also drops the particles out to improve the BOD, so you clarify the water as well. They also help in preventing algal growth, and they will improve the water quality. Just started the meeting, one of my goals is to be able to get floating wetlands on the Torrens to clean up our beautiful water body. So anyway, I'll keep working on that one. And the other thing is they reduce CO2 emissions, and by taking up the nutrients, you're going to harvest the plants and you sequester the carbon. So we'll have a chat about how these can be used. So I'll just give you some features of the floating wetlands. Wastewater treatment, water and wastewater treatment. Here's wastewater, for example. These are all just a list of technologies used for treating wastewater. So I'm not going to go through any of them, but they all have the same constraints. Generally, it's a high capital cost, and I'll be fairly general here. High energy costs, operation and maintenance, and you also need to look at the environmental costs and the harm. Floating wetlands, just use the disclaimer, majority of wetlands in the presentation are ones produced by Clarity Aquatic. And that's my role as a CEO of Clarity Aquatic, which is all these modules were developed in South Australia and they're built here in Adelaide. And then we ship them all around Australia and around the world. So all from little old Adelaide. Take a step back. This is probably familiar to all of you. Types of water-sensitive urban design measures. There are a number of different measures used to manage stormwater quality. And so you got like green roofs, constructed wetlands, you got bioretention basins and floating wetlands. And this isn't an extensive list, but it's just a bit of an example. But today we're going to focus more on the floating wetlands. The two main types of wetlands are constructed or surface flow wetlands and constructed floating wetlands. So I'll just give a little bit of a background. So surface flow or constructed wetlands, the water's open to the atmosphere. It mimics a natural wetland and gives the additional benefits of aesthetic values, provides a habitat for birds and aquatic life, and they're most often used to treat urban, agricultural and industrial runoff. Constructed wetlands, high ecological value for fauna and flora. They're aesthetically pleasing. They give passive recreational use and give a high level of treatment, particularly when the water's flowing into water bodies. It will give you some preliminary treatment as the water goes into the lakes or water bodies. There are some disadvantages. I'm not saying this is common, but they can require resetting where the sediment buildup is impacting plant health. They do take quite a bit of land in comparison to other systems. They can be sensitive to prolonged inundation. Depending on the environment, you can get mosquitoes and odours. And sometimes birds can be a nuisance, especially if you're replanting. And once water's passed through a surface wetland, the water isn't always then continually being treated by the plants. So it treats it as it comes in, but it's not always treating it on a continual basis. This is an example of a floating wetland. It's a novel approach. It provides treatment similar to surface flow wetlands, and it's using a nature-based positive treatment. The main difference is the plant roots grow down into the water, and I've got an example coming up to show you a bit more. So essentially, we're using hydroponics. The plant roots reduce the velocity. It helps with the sedimentation. The roots provide surface area for microbial biofilm growth, and I'll show you that again in a minute. And they also help cool the water, and they can provide a haven for aquatic life. We're talking a little bit earlier about platypus. We've got a site in Tasmania where the platypus, it's actually a waste treatment, an effluent lagoon, and there's platypus living in there, and then they actually get up on the floating wetland. So there's another one. We were just talking about platypus before. They help cool the water, and basically the number we normally use is about 50% of phosphorus and nitrogen can be removed. They sequester carbon, and if you're using on effluent ponds, they can reduce the CO2 emissions, and we look at these as contributing to a circular economy. If you look at the floating wetlands, I don't know if you saw earlier the way the modules look. I think you can see these are like each of these modules. This particular one has got 3 modules wide. The modules are 2.35 meters by 2.35, and they link together. So if you and inside we've got baskets. So this is what the baskets look like there. And so that's just looking at cross-section of the floating wetland. So all the modules link together to form an island. And each module's got 15 slots, and you put baskets in, and We put about 15 litres of river pebbles or gravel in there, and we put a couple of plant rootstocks, and then we sit them in the module, and then the roots are actually sitting there in the water, and the roots grow down into the water column, and it forms a biofilm. So you can see on the right-hand side there, the biofilm, and that helps trap particles, and the particles drop down to the surface, so it clarifies the water, and then the plants then uptake the nutrients from the water. So mainly phosphorus and nitrogen. We have also done some trials where they can remove PFAS and heavy metals. So it's, as you can see, it's just using nature in order to clean the water up. Where they can be used, you can use them in water treatment lagoons, dams, housing estate, stormwater lagoons, wastewater treatment lagoons. Quite often, water from a wastewater treatment plant will be released to the environment. And what this will do is polish it up and remove nutrients before it's released. You can use them in farm dams. And for example, in a farm dam, you can also mount some solar panels on there, have a little pump up to a stock trough. And once the stock trough's full, it just recycles and it just keeps the water clean in the dam. Golf courses, mining, stormwater, virtually any water body, you could actually fit a floating wetland. This is just showing you a few. The Clarity Aquatic ones, which is the one down the second one from the bottom, is the one that we make. The guys who founded it were working at the Uni SA, and they are environmental consultants from Queensland, a company called Covey Associates. They had been working for many years in designing and implementing wetlands, and they could see that there were issues with what was on the market. The stability, a lot of things are made from recycled plastic, for example, recycled PET bottles, and they would break down and release microplastics in the water. They weren't very stable, and if you get a storm or something, they would break up and fall apart. So what they did was they sat down and designed something that was robust, stable, was long-lasting, and they came up with the Clarity Aquatic wetlands. So you'll see a lot of wetlands around, and they've all got their purposes, but I think I'm quite pleased the fact that I was able to work with Clarity Aquatic and come up with something that was truly sustainable and long-lasting. So if you look at them, they're made from UV stabilised low-density polyethylene, and they've got a estimated life of 50 years. They don't degrade, so the UV stabilised, and they don't release microplastics in the water. They're fully recyclable, end of life, so they just get ground up and reused again. The ones we are making, they're actually made here in Adelaide. The rotomolder is a company called APR, and APR specialise in reusing plastics, use recycled materials, and they make a lot of walkways and posts and other bits and pieces. So they're fully recyclable, they're stable, flexible, buoyant. You can walk on them, and I'll show you shortly how that looks. Because they've got special keys that join them together, they can be reconfigured if you want. You can add to them, you can move them, you can be relocated. Very easy to install and maintain. The only thing you have to do is then harvest the plants. So you just go in there with a brush cutter, cut off the top of the plants, that gets mulched, reused, and the biofilm, the root mass and the biofilm stays there, and the plants just keep on growing. And we have done some trials where we've removed PFAS. For example, out at Mawson Lakes, there were some trials there, and actually done with CSIRO and UniSA, And we currently have a trial we're working at with the City of Salisbury out at Burton. And that's doing the trials to getting water that comes off the Edinburgh Raft Base. And they're actually measuring what the PFAS removal is. The plant creates a removable, so very easy for maintenance and weeding. The inbuilt walkways, you can you walk out on that and you feel very safe. And if it's a large one, and for example, a wastewater treatment plant, we can fit handrails and walkways, so you can just walk straight onto them. And when they're young, we put bird netting over to protect the immature plants. And usually after about 3 months, the plants have established and you can just remove the bird netting and leave them all natural. The main thing is they all do the same thing. They grow plants, they remove pollutants, improve the water quality. So there's a couple of examples there of wetlands. The one down the bottom is one of the ones that we had, which is in a wastewater treatment plant up in Queensland, and you can see the plant growth there. It's amazing. That's one of my colleagues walking along the wetland. So I'll just run through a few case studies and give you a few examples. This is a job in ACT. It was done with ACT Healthy Waterways, and when the stormwater comes in, if you look at the bottom left, you can see a little basin there. This is the photo was taken just when the basin, when the islands were built, and just to the left there, the stormwater comes down into this little basin, and they were getting lots of algal growth, and the water quality was really poor. And so they put one in where it comes in the basin, then it goes under that bridge to the second island, and then out into the lake. And then the top photo you can actually see looking from the inlet to where the city of Gungahlin in the background. So the top photo shows you where the water comes in. There's one of our friends, just the swans swimming around as we installed it. And the bottom photo I've written there, plants remove nutrients. I took that photo about a month ago when I was in Canberra, and you can see the wetland there. It's nice and established. The water's a lot cleaner. I spoke to one of the neighbours and she was really happy. So it was very, very positive outcome. And now this one here is for Taswater. Taswater have about 40 plus, or 40 or 50 treatment lagoons, and most of them only rely on aeration for treatment. So the water comes in, it's got a retention time of 2 to 3 weeks, and then it goes out and it goes into the environment. We've put floating wetlands on 3 sites at Ross, Fingal and Western Junction. And the idea is that their target was to remove 40 to 60% of phosphorus and nitrogen. Down the bottom right is the site at Ross. They do have primary treatment. That's the only one of the sites. But the water goes in, and it's directed with baffle curtains under the wetland, and it goes out under the second one, and then it goes out the far end there. Results to date have been very positive, and you can we've even got swans who have formed nests on the islands, and you can see the growth up the top left there. And the photo down the bottom left gives you an indication of the buoyancy. And you got 1, 2, 5 plus me, six people standing on this island, and you feel safe as anything. So buoyancy is great, and we're just examining the site there. You can see on that one there we actually have bird netting, that bird netting was removed once these plants had established. This is an aquaculture farm in Northern Territory. So they've got a series of ponds, and obviously being aquaculture, you're going to get nutrients going into the water. And you can actually see that island there, how vigorous, how the plants are growing. You can see there that the root mass, and obviously you get a root mass like that, you're going to get really good removal of nutrients. And I think after about 3 months, you can see the growth where they're doing some harvesting there in the bottom right. They're just now looking to double the size of that. And they've got 2 more sites that they want to put wetlands in. This is a resource recovery centre in Caloundra in Queensland. That one there, they've got green waste, and they wanted to, the water gets collected in this basin, and then once the water is of suitable quality, it's then released into the environment. We put the initial wetland in, and that's a 3x3 module. And they ended up harvesting 3 times a year. So significant plant growth. And you can imagine that if that's growing up to 1.5, 2 meters high with those plants, it's going to be removing a lot of nutrients. So we're now in the process of putting 2 more islands in on that site, and that will help them remove all the nutrients before they're released to the environment. You can see the bottom photo when it's harvested. Looks like they're dead. Within about 2 weeks, you'll see the green and everything shooting up again. This is a job on Phillip Island. This is a Cowes wastewater treatment plant on Phillip Island. They were particularly interested in this one because this is the effluent lagoon, and they're actually doing online monitoring. And in this one here, they're actually they're working closely with Deakin University, Blue Carbon Lab, CSIRO, and they're very interested in measuring the actual removal of PFAS from that lagoon. So this is a housing development in Queensland, Tewantin, and in this basin, you can actually see when they installed it, there wasn't much there. And the idea is when they get runoff, they want to treat the water before it gets released. So they've installed this floating wetland in here, and it's filling this initial basin. And you can see when it's growing. And nowadays, you wouldn't know it was there. And that can rise by up to 2 meters. And it's stable. It'll clean the water up and release it. So I just want to give you a bit of a picture of some of the other uses for it. This one here was a project in Alberta, Canada. The main idea I wanted to show you here, you can actually see bottom left, it gets a bit cold there, and that lake freezes, yet because these are so robust and stable, even though it's frozen, the modules stay on. The plants just go into dormancy. As soon as it warms up again, they'll start growing and then keep removing the nutrients. I'd just like to throw a few things, bit of thought out there. Sometimes you might be using aeration. You might have a pump or something like that, or you just want to be able to utilize the water space, and you can actually, there's no reason, these are because they're so robust and stable, you can actually mount solar panels. So these can be used for cogeneration. Sometimes they'll actually put solar panels on the banks, but there's no reason why you can't actually have a selection of plants that are slightly lower on the northern side, and then have some taller ones at the other side. This is an example that I have, and it'd be perfect for somewhere like, I used to work for SA Water, and if you look at Bolivar, for example, you've got all the lagoons out there. Why not have a combination of floating wetlands and cogeneration on some of those dams. So the opportunities are endless, and I'll leave it there and I'll open up to hand it back to you.
That's brilliant. Thanks.
Kim.
Thanks,
That was
Kim.
really interesting.
Yeah, absolutely fascinating. I have a few questions.
Go for it.
But yeah, I also will open up the chat to make sure that everyone else also has the opportunity to chime in. I guess my first question would be the sort of environments that you typically install these in. It seems like freshwater. Have there been any applications in saline environments at all?
Not that I'm aware of, but there's no reason why they can't. The only thing you'd have to do is make sure it's the plant selection. So basically what we do is we produce the modules, which gives you the ability to set up the floating wetlands. And I think that would be ideal for, let's say, for example, the Coorong. There's opportunities down there, and you can use them for coastal protection because they're so robust and stable, they would help any wave action. It would sort of take that out of the equation. And if you have plants that will actually grow there, and I'm sure there are plenty of plants, this gives you the perfect mechanism to install them. So, no, good question.
That's great. Thanks, Kim.
And
I'll just say one more thing with the plants. Our company hasn't been going that long, so I'm actually in the growth phase. So I'm looking for more and more opportunities, and I've identified a number of areas that I'm working with and targeting. That saline solution, the saline waters, is certainly an area that I'm keen to pursue.
That's brilliant. Thanks, Kim. Yeah.
And with the plant selection, does it depend on, I guess, the environment and location as to which plants are selected to do, I guess, the best job in that area?
Yes. So we'll generally use local plants, native species. So typically for most of the environments, we'll use something like Phragmites australis. We've used Bomea articulata, Schonoplectus, Bulbochenus. So and we usually work with local nurseries. So we won't march in and say you've got to use this or got to use that. We'll find something that is suitable for the environment, and ideally something that's going to grow well and remove those nutrients.
Yeah, and I guess if they're native, then it's more likely that local bird species and insects will want to get around it and make a little home.
Yeah, look, if you imagine if you had something like this on the Torrens, you'd have bird life would have a haven. You'd have hopefully you'd have turtles, and eventually you might even have platypus. Surprise, surprise.
We're all team platypus.
Yeah,
we are all team platypus.
Got a question. In the basin scenario you shared, do you see any risks with the basin drying for extended periods and the plants rooting into the soil, then the roots rip on the first large rain event?
But basically, obviously the plants need water. Some of them, the plants will actually grow if it's very shallow. The roots can grow down into the soil, but what you'll find is because these are so robust, and that site where I showed at Tewantin, when that water rose, it rose up about 2 meters. They had a significant rainfall event. And I suspect with what they've just had up in Brisbane, they're probably getting something similar. Yes, you can. All you have to do is make sure when they're anchored, tethered, that you allow for variation.
Just had a question around if, like, the water quality that kind of comes out of whether it's lagoons or anything like that might actually be okay for aquifer recharge. And I know nothing about this, but then I sat in on a discussion last week where someone highlighted that because of our dependence on the River Murray, a lot of our water, I guess, like South Australia, is in a kind of a problematic area because we're not doing enough aquifer recharge as well. So I know a lot of it's kind of like potentially going out into the environment, but I would assume, again, someone that doesn't really know this science very much around like water quality, if perhaps these kind of solutions can also help with aquifer recharge rather than just environmental discharge, or however that goes. Probably need to be educated a little bit more on that, but it's just a question to throw out there.
Ken, I'm happy to give you a bit more information. With my background, I was actually instrumental in helping get the water from Glenelg Adelaide Parklands, the GAP scheme. So,
Thank you so much. That's a great
so,
legacy.
so I was the one who helped get that actually approved, and so that's now taking treated sewage and effluent, so it's tertiary treated, and that supplies the parks, the West Parks. It supplies Unley and supplies the whole of the city with the purple pipe. There's another scheme I was involved in, and at the south end of the airport, you've got the PAT, where the PAT goes out. There's an aquifer storage and recovery scheme there. So when the water's flowing, it'll actually treat the water and pump it into the aquifer. There's another couple of schemes I was involved in. There's one down at Christie's Beach, which is the scheme that supplies the Vales with the water. And the other one is out of Bolivar. They treat the water and it pumps up to the north. But there's one significant one, which I think is along the lines that you're talking about. The system that goes into Mawson Lakes, they're taking treated effluent. Originally, Mawson Lakes was going to do on-site treatment and reuse the water as third pipe. What happened there, there was too much saline water getting into the aquifer where they wanted to use it, so they couldn't use that water for third pipe. So what happened, that then got sent out to Bolivar and to the another treatment plant there. And then they took the treated effluent from Bolivar, pumped it back to Mawson Lakes, and they mixed it up with the ASR water from Salisbury. Mm-hmm. And then they had a CT60 chlorine contact time of 60 minutes to ensure that it was disinfected, and then that's used as third pipe for Mawson Lakes. So that is aquifer storage and recovery water.
There's some great examples.
Yeah.
Yeah.
So if anyone wants to know any more details, I'm happy to help that. I did get involved in most of those projects.
That's brilliant. Thanks, Kim. I've got another couple of questions up my sleeve. So one of which is the frequency of maintenance. So obviously you go in there, you strip your plants out. Is that an annual thing, or is it how frequent?
Look, generally, there's a very low maintenance. Usually in the first 3 months, it's just a matter of walking in there and pulling weeds. Occasionally plants will die or get taken by birds or something, and you just put another plant in. After about 3 months, they pretty much stand on their own. And then it's maybe just a monthly check, make sure there aren't weeds taking over or anything like that. And then it's pretty much annual harvesting. And normally depends on the amount of nutrients in the water, but generally once a year a harvest, and depending on the size of it, it could be 4 or 5 days or maximum 2 weeks for a couple of people, and that's all it would take. So there's no general day-to-day maintenance, no power costs. If you're talking about treated effluent, you may have aeration, because that will enhance the treatment process. But other than that, basically there's no power. Just go sit there and have a cup of tea or coffee and watch the plants grow.
Love it.
And do you guys provide that maintenance service, or is that something that the landholder or property owner has to do?
Look, not we can provide the guidance for what needs to be done, but it's fairly basic. So no, we don't, but we can arrange it if need be. But most people have their own teams, and it's really relatively easy to do.
Great.
Excellent. Thanks, Kim. Another one that I had as well, which was, I guess, a tie-in with your opportunity for cogeneration, was reading about, I guess, our friends over in the US and how the canal that goes from northern to southern California they've trialed some installation of solar panels, which has actually reduced evapotranspiration, and they're saving gigaliters of water a year in those locations. I was just wondering if there's any sort of similar studies across this way that I guess has looked into the potential benefits of that sort of reduced evapotranspiration in the high heat of summer, and whether or not, sort of on balance, that would potentially reduce the amount of water that's lost.
Look, certainly with floating wetlands, the water's going to be cooler, and it's ideal if you are going to put solar panels in. They're more efficient because they're over water. It's cooler, and you're going to reduce the evapotranspiration. So, yes, I agree with that, and I tend to find that it's easier for me to get projects interstate than it is in South Australia. I don't know why, and you may all have experienced that. But this is my back doorstep, and that's why, for example, I mentioned Bolivar. Now, Bolivar is a perfect spot where you could have solar panels on. You've seen how big the lagoons are there. Why not have solar panels there? And you can have a combination of solar panels and plants. So you're actually improving the quality of the water, you're generating power, and everything's happening at once.
Absolutely, Kim. And I think, one of the beauties of the Adelaide Sustainable Building Network is obviously we are hopefully going to then be able to spread the tendrils, and those on the call can link people up, because of course, very, very good outcome for co-benefits of water quality and in addition renewable energy generation. So I'll certainly be linking up with a couple of my colleagues after this meeting, and hopefully we can all do the same to help these great benefits become realized.
No, thank you, and I think it's thanks for the opportunity to speak to people who are like-minded. You've got sustainability at heart, and I will say that I even though I've been involved in reverse osmosis and just about every all the energy requiring treatment solutions, to suddenly now have plants which is truly sustainable. I think it's terrific.
Absolutely. We love nature-based solutions.
Yeah. It's the way to go.
Yeah, very fascinating. Agree, Kiri. Thank you. And thanks again, Kim. Really, it's been brilliant. And it's really good to know that you are on the doorstep. And I'm very much looking forward to, helping create some of those networks and links, and hopefully
seeing a lot more floating wetlands about.
Absolutely. Maybe a couple of platypus eventually. You'd be the first to know.
Thank you. And look, if anyone's interested or wants more information, you can always connect on LinkedIn as well. So on LinkedIn, I try to keep posted on various activities and projects and case studies and whatever's happening. And if you've got any questions, feel free to just reach out.
Absolutely. Will. Brilliant.
Thanks so much, Kim.
Thanks heaps. And thank you all for joining. It's been a really interesting one. Appreciate it, and we will see you next time.